Okay, let's take a look at the solutions quiz, molarity and other solutions. We have a dilution problem. Here's my equation. It doesn't matter which one is M1 and M2, just keep track of which one is which in your amounts, and also keep track of your units to make sure we're describing the same thing. So let's take a look, 0.75 molar, and I have 350 milliliters. I like to label that to make sure it's consistent, and so my other concentration is 8 molar, and the question is, what is my X? X in this case ends up being a 32.8, which I'm going to go to two significant figures, so that's 33. Now that means 33 milliliters of my stock solution. The question is, how do I actually make it? Well, I have 350 milliliters total minus my 33 milliliters of stock solution, so 317 milliliters of water. Okay, you add the acid to the water, and you have your two values. So that was a 2-point question. Now this one, we take a look. There is a hidden trick here. Here's my equation. I have 2.0 liters, and I have 0.75 molar. Okay, so the question is, how many milliliters of 18 molar stock solution? And so there's my X. However, you got to be careful. When I solve for X, I ended up with an answer of 0.083, but that is in liters, and this problem is asking for milliliters. So make sure you do that one last step, and that's 83 milliliters. Okay, now we have this problem that's taking a look at molarity. Here's my equation for molarity. Moles of solute over liters of solution, and we see that we don't have either one. So 15 grams of my potassium chlorate. And if I take a look at the formula mass of potassium chlorate, that's 123. And so I ended up with an answer of 0.122. And so that's going to be my moles of solute, but I also have to convert this guy into liters. So 0.122 divided by 0.25, and so that's going to give me an answer of 0.4878. Okay, and so if you go two significant figures, that gives me an answer of 0.49. That label on that is capital M for molar. Now we take a look at the next problem. It is in liters, so I just have to convert my grams. So 1.7 grams of calcium chloride, and the formula mass on calcium chloride is 111 grams per mole. So I ended up with an answer of 1.7, oops, I'm sorry, 0.0153, and this is already in liters, so I just have to divide that, so that's 0.75, and I ended up with an answer of 0.0204, which gives me an answer of 0.020 molar. Okay, now let's take a look at number 5. Now we're going to find how many grams, and notice that we're in molality now. Very similar, but look at how much the formula changes just in the denominator, kilograms of solvent. So my molality is a 1.75. Remember, we use a lowercase italicized m. So that's going to equal X moles of solute over 0.075 kilograms. Okay, because we have 75 milliliters. 1 milliliter is 1 gram, so I have 0.075 liters. That's 0.075 kilograms. I get an answer on this one of X equals 0.15. Now be careful, because that's moles, not grams. So I have one more step to do. 1 mole, in this case, is 56 grams. So I ended up with an answer of 8.4. Okay, so that's that one. Now, let's take a look at the next problem. We're looking at number 6. So in number 6, we take a look and we say, I have 1.75 molol solution. Okay, so 1.75 molol is my solution, and I have 2 kilograms, the same thing as 2 liters, so 2.0 kilograms of water, and so I'm solving for X, but that's going to be in moles. This problem is asking for grams. X ends up being 3.5 moles of calcium chloride, and we've already done this formula mass, so that's kind of nice. 1 to 111 grams, 1 mole, and so I ended up with an answer of 388 0.5 grams. And if I go 2 significant digits, I get 390 grams. Now, percent solution, watch out, this is grams of solution. Remember, there's solute and solvent. Okay, and so watch out for that. And we see that this is in liters. Well, remember, liters, we have to convert that to milliliters. So that's going to be 1,500 because liters, milliliters is 1 gram of water as well. So now I've got all the pieces in place and I can answer the question. Now I have 5.0% equals X milliliters over 1,500 liters. Okay, we have 1,500 milliliters total, and so now all my units agree. If I multiply both sides by 1,500 and I get X by itself, X is going to equal 75 milliliters. Watch out, this is multiplying by 0.05 when I get that into a percent. Now this problem is saying that I have 75 grams and I have 100 milliliters total. So we're in the units that we need, and it is in solution total, so I don't have to do anything fancy here. And so we end up with, in this case, we want to find our percent. So my percent is simply 75 divided by 100, which is 75%. So it's actually a pretty easy problem if you take a look at that way. This one does tend to trip some people up because we have to figure out the solution and we have to get it out of the denominator to get X by itself. So just watch out for those couple little tricks.